Hello, Algebra 2 students. We're again in our complex number syllabus. We're in Tier 3, Lesson 3, writing complex number quadratics. Let's check off our book, and here we go. First thing we're going to talk about is that a quadratic that has two terms, imaginary roots, in the form a plus bi, the roots are always complex conjugates. Therefore, if you're told one root is 2 minus 3i, you know the other root is 2 plus 3i. This happens naturally with the quadratic formula because the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, is going to give you a number plus a number, which could be imaginary or real, over a number, and a number minus a number, which could be imaginary or real, over a number. Moving on, if we use the root 2 minus 3i and find the factors, and recall that we want to put it in the form x minus p and x minus q, and be careful with your distribution here, we get x minus 2 minus 3i as one factor, and we get x minus 2 plus 3i as the other factor. And distributing carefully, our simplified factors are x minus 2 plus 3i and x minus 2 minus 3i. And we can use the Punnett square here to put this in the standard form, and we want to use each term, so we need a 3 by 3 Punnett square. So we have x minus 2 plus 3i here, and we have x minus 2 minus 3i here, and we get x squared, we get negative 2x, we get positive 3xi, we get negative 2x, we get positive 4, we get negative 6i, we get negative 3xi, we get positive 6i, and we get negative 9i squared. This term and this term, combining like terms, cancels, as does this term and this term. And then we know because I squared equals negative 1 that this term is now just positive 9. Now if we combine our like terms, we get x squared minus 4x from this 2x and this 2x plus 13 from this 4 and this 9. So our standard form of this quadratic equation is x squared minus 4x plus 13. There's another way to do this to find our standard form. We can use the idea that we had earlier where roots are of the form x minus p and x minus q. If the roots are complex conjugates, we know that we have the factors of x minus 2 minus 3i times x minus 2 plus 3i, and that can break down, and we can distribute that negative, and then we can use the commutative property to redo this here. So this can become x minus 2 plus 3i, and this one can become x minus 2 minus 3i, and then we can group this and this together. If you remember from before in previous lessons, we said a plus bi times a minus bi is equivalent to a squared plus b squared. We can make this our a term and this our b term. And if we do that, our a term would go here as x minus 2 and x minus 2. And that would give us x minus 2 squared in the box here. And then our b term would be positive 3i and negative 3i. And in this box we would have 3i times x minus 2. And in this box we would have negative 3i times x minus 2. And then here we would have 9i squared. So if we simplify These two terms cancel because everything's the same except they have opposite signs. And we know that this term will simplify into just positive 9. So if we drop down here, we have x minus 2 squared plus 9. Well, if we factor this out, if we distribute this out, we get x squared minus 4x plus 4 plus 9, which, again, if we simplify further, we get x squared minus 4x plus 13. And then this standard form matches the standard form that we found earlier.